Hi. Well, so in the United States, we just finished a presidential election. I'm sure most of you know. And the thing that came out of this election a lot was what we called instant fact-checking. So I have to do some instant fact-checking on Joe's introduction right there. I haven't built 300 buildings around the world, but I have facilitated the construction of 300 by teaching other architects and training building contractors in California and throughout the western United States. So we've had a great deal of success in introducing earth as a legitimate building material. And then it hasn't been 35 years I thought about it, it's been over 40, because when I first graduated from Stanford, I began playing around with earth as a building material. Now, I say 35 years because those first 10 years were what we call illegitimate. In other words, we were building under the radar, experimenting with things without building inspectors. So how many building inspectors are here tonight? Okay, we're safe. But Joe is right that I have a passion for this wonderful material. Earth or soil, and we don't call it dirt. Dirt's what's under the refrigerator. But we have learned how to quantify it and classify it and make it what we think is a legitimate building material. Now that was a really, really hard thing to do. At the very beginning, the early 1970s, I had this idea from reading some stuff at Stanford that you could take soil and mix it with cement and create a structural material. The U.S. Department of Energy, the federal government, the Army Corps of Engineers, a lot of people had done a lot of work with earth and had discovered that it held up really well. But we weren't using it to build houses, we were using it to build dams and underlayment to runways and roads. But also in the middle of the Depression in the United States and even in Canada, a lot of people were experimenting with this technique called rammed earth, which is the one that I started with and got infatuated with all the problems there were to solve, because what I really am is a problem solver. But this rammed earth technique, where you take soil directly from the base of the wall and you have a little moisture into it, and you dump it inside of a strong wooden form, and you ram it layer at a time, lo and behold, it becomes durable, much like sedimentary rock. Now the key is that the soil has to be just right, and the moisture has to be right, and the compaction has to be right. But basically, you can take soil and restructure it into sedimentary rock. Well, once I discovered that technique really worked, then I couldn't think of anything else. I couldn't think of anything else except Cynthia for maybe 20 or 30 years. Well, Cynthia and my children and Joe and a few other things. But basically, I was challenged to create a respect for this material and this construction process. Now, being 25 years old when I started, I thought it would only take a couple of years. I thought I could build a few buildings, get someone to legitimize it, someone to take it over from me and start building tract houses using rammed earth in California, because this was the late 70s and the early 80s, and everything natural was really, really popular and in. So we weren't wearing Birkenstocks, or we weren't eating potato chips out of natural brown bags, but I thought we were building natural houses. Thermal mass, no chemicals, very little cement, reusable formwork, and I thought everyone would love these houses, and that was the mistake. The problems weren't in solving the engineering problems, they were in overcoming people's prejudices about earth. So turns out that people don't trust earth as a building material. We hear about earthquakes around the world where mud buildings collapse and kill hundreds and thousands of people. Thousands of people anyway, not hundreds of thousands. But that's not because the buildings are built out of earth, that's because they're not built well in the first place. But you've got this inherent prejudice that haunted me for years and years and years. So we changed our tactic, and instead of inventing this system that other people would adopt, and then I would go on and invent something else, I became a building contractor. Terrible line of work, especially if you're an innovator, because an innovator is compelled to change things constantly, and a building contractor is contracted to do what he promised the client that he would do at the start of the project. So I had a disconnect that haunted me for a lot of years, and I had a few unhappy clients. But struggling and struggling and struggling, we finally got over some threshold where we had built 10 houses or 15 houses or been in 30 magazines or been on TV 5 times, and then people trusted it. Realtors were selling rammed earth houses, bankers were investing in them or giving clients money, and insurance companies were giving insurance on them. So we reached this threshold, we moved to the Napa Valley, and lo and behold, rammed earth became appreciated. This was in the early part of the 1980s, and we were building wineries and houses for well-to-do people, people who had traveled someplace to Europe in their lives, and so they had this confidence. And we overcame this threshold of distrust in earth, and from that point on, things got really exciting and really rewarding. But lo and behold, I had another idea to change the whole construction technique, and I'm going to tell you about that. So that was a long introduction. You know a little bit about me, but what I want to show you is some of the techniques that we have developed, I'd even like to say mastered, to allow us to call this wonderful, humble, venerable material that is everywhere, completely sustainable, recyclable, into a legitimate building material. Now, we can start with the slides. I hope. Excuse me. Okay, so this is how rammed earth begins. You know, this is Bhutan. These guys are up on a form ramming moist clay and sand into that sturdy wooden form, building this structure that is historical Bhutanese architecture. You can see this technique all over the developing world, in China, in Africa, in the Far East, in the Near East, even in, it's a little bit more primitive than you see in Europe, but basically people have known for 2,000 years, 5,000 years, how to take moist soil and pound it down into a form and turn it into durable structural walls that support roofs and keep people warm and dry for 50 years. This building would last for 50 years, and then it would dissolve or fall apart to the degree where they gathered up the soil and they built it again. So that is recycled, cradle-to-cradle construction. But what I worked on over the years was trying to take that confidence that we had in that primitive technique and make it a little more first world. So we developed forming systems, delivery systems, mixing systems, quality control processes, testing protocol, architectural specifications, and year after year, project after project, we moved forward with this technique to where it created buildings that architects and engineers recognized. And fortunately, architectural magazine writers and people who helped us get to the next project and the next level came about. So this project is the Las Vegas Springs Preserve. It's in Las Vegas. It's an educational center, teaches about sustainability and energy use and water use, and 50% of it is built out of rammed earth. Then a couple of years ago, we built the Child Care Center in Glendale for the Walt Disney Studios, where they have, this is an entire city block of rammed earth walls. And it's a child care center, so we know that it's safe enough that you can feel confident in putting your infant into it for the year.
David, can I just move the arrow off the screen?
Yeah, I'm sorry.
That's all right.
And then we do a lot of single-family residences, and here people fall in love with the mosaic, the aesthetic quality of the earth wall. And another residential project. Now, one of the things that discouraged me about rammed earth over the years was that accidentally it became expensive. When I began as this idealistic youth, willing to work super hard to make this construction method viable and affordable, it was relatively inexpensive. You had the beauty of not going to the hardware store or the lumber yard and buying all of these other building materials. There was no fiberglass insulation, no wood framing, no sheetrock, no paint. These were these raw earth walls that were the interior and the exterior. And my buddies and I, when we were in our prime of our lives, would work really hard and really fast and not charge very much money to our clients because we wanted it to be affordable. And then the accident happened when we came to Napa Valley. The architects were designing these houses rather than me throwing them together off of some plans from the supermarket. And they became harder to build. And the clients wanted them crisper and better. So this idea that you had this rough, rugged, earthy wall full of texture and maybe a corner that was broken and it was only close to plumb. It's kind of like straw bale, not exactly level or plumb, but it had this rough character. Well, the architecture profession in Napa were writing tighter specifications. So what I saw through the early part of the 80s was this transition from it being rough and rugged and affordable to being sophisticated, refined, and expensive. Why was it expensive? Because we used to use laborers and we would set this reusable formwork as fast as we possibly could and get it within, if the bubble was between the lines, it was close enough to plumb, was sort of what we joked. But all of a sudden, instead of using laborers to set this form, we were using carpenters. Well, carpenters get $50 or $60 an hour and laborers get 15. And then the carpenters work half as fast as the laborers, so you're 4 times the cost of setting every square foot of formwork. And then you had to screen your materials more carefully. So what happened is that instead of it being inexpensive, it became expensive. And where am I going with this? This motivated me to try a new method of building with earth. So rammed earth, expensive formwork, careful selection of soil, layered carefully into the form. Everything had to be just right. I had the idea that you could take earth and you could shoot it with high pressure air through a gunite gun, and wow, you could build the wall 3 times as fast. So this, and I call this technique pisé. There's the gun, and the machine mixes the soil, dumps it into the gun, the guy shoots it against the wall, and then while it's still tacky, another guy shaves it off and makes it straight and square. So the beauty of pisé over rammed earth is you've got a single form set up on the inside of the wall, half the cost of forming, actually 1/3 the cost of forming because it doesn't need the bracing. And then you shoot this material against the form really fast, moving it with this air, high pressured air, and then you shave it off so that it's flat and, straight, but not flat, and we came up with this European stucco finish. We called the technique pisé, pneumatically impacted stabilized earth, and I thought that was catchy because the rest of the world calls rammed earth pisé de terre. Well, pisé was really popular in Napa and around Northern California for 15 or 20 years. We built a lot of big, tall wineries. We built this project for Herzog and de Meuron in the Napa Valley, which was kind of fun working for people with that level of a global reputation. And oh, these are fun. Let me show you these. So this is the project for the winemakers at Herzog and de Meuron. And then inside is what a pisé wall looks like on the formed side. So you saw some of the pictures of rammed earth. It has this horizontal look, kind of a toothy character, looks stratified, it's really earthy. Well, pisé has a very, very smooth, uniform finish because when that material comes out of that high pressure air with a little water on it, it really consolidates itself against the formwork. So you have an inside surface that looks like this, and then a outside or a toothy surface that you see on that fireplace that looks like that. And then we come to an adjacent building that you could call more of a block house shape to it. This was the caretaker's house outside the gate of the other people's houses. And here you have a little square window, and even you can shoot pisé up over your head onto soffits and things like that. So that technique of shooting earth was kind of exciting for me because I had this opportunity to develop a whole new set of tools and specifications and methodologies. And as I said earlier, that's really what I do, is develop systems as opposed to design and build buildings. But so we did pisé, and you'll see where I'm going with the bragging about developing systems. But we're going to get off tack just for a minute, and I'm going to show you some of the processes and the materials itself. So earth construction begins with a pile of soil. And you can approach it as simply as this: piles of soil, add water to it till you get this moisture as you require for building. And so this is a project that we worked with in Kenya. And then here we see a project in Mexico, the state of Veracruz, where again we did hand mixing, delivered the soil in buckets to the formwork. Formwork is a little more sophisticated than you saw in that Bhutanese picture. But we still have something simple and reusable. The people are on top of it, ramming the walls with hand rammers, and as you can see in the buckets and the soil in the foreground, we carry it up with hand tools. Now we also have a hand version of pisé which you can see this guy is mixing some soil like muddy in this consistency, and then he's throwing it against this one-sided form to fill in this space under a window between the two rammed earth walls, and the material gets packed up, smoothed out, and then finished on the inside, as you see here, with plaster. So that project was a preschool that we did in the state of Veracruz as a workshop with 15 or 20 people from the community, half of whom would have their children enrolled in that school. We used bamboo trusses on the roof. So clearly a sustainable, locally sourced building with technologies that we have been able to bring to these people. And the exciting part about this to me is after we did that building, a group of the masons who had worked with us in the workshop became rammed earth builders, and they've now done a dozen other rammed earth buildings in that community. So what we have to do is to find a suitable material, because we can no longer go to the base of the wall and be fortunate enough to dig up anything that's there and turn it into walls. But we typically will go through a process of screening our material, blending it with sands and other things that might give it strength or a better durability or a better resistance to moisture intrusion. And then we have this forming system that I've put together from components of the concrete forming industry. And with that big form and this delivery equipment and a lot of people running pneumatic rammers, the process of building a wall has become relatively fast, so that we saw this picture in a couple of others. You have a rectangle here that is 24 feet by 20 feet by 8 feet high, and with all of those people running rammers and that conveyor delivery equipment, you can build a room like that in about a day. It takes 3 or 4 days to set the formwork, but then with all those people, it takes 1 day to build that rectangle. So here on this project, you see 3 of those rectangles and 1 open corner in the center. Now, the Pisé equipment is a little bit more expensive, takes more diesel fuel to operate it, but here we're using a mixing machine. We're loading soil into the machine with a tractor. We are using these screw mixing devices, screw feeders, cement hoppers. This stuff is available and purchased by the gunite industry, but it's allowed us to build rammed earth faster. And then, of course, we use conveyors to deliver the material into the formwork, so that we've eliminated that tedious part of it, which is shoveling everything into the work. So we're back to technologies. We're back to improving things incrementally so that earth can have not only a place as a quality building, but as a kind of a modern building to put together. Now, Pisé, as we talked about, has a different forming system. Here you see a formwork set for one of our Pisé buildings. The boxes that are attached to the face of the form are used to create door and window openings, and then the guys are getting way up in the air on this equipment to shoot this material against that single-sided form. And right behind the guy doing the nozzle work is the guy who you saw in an earlier photo shaving the wall to make it flat and straight. And then we take the formwork down, set a roof on top of it, and boom, the building is finished. Now, formwork is really expensive, so in this picture here you see a much more complex version to create a taller wall. The wall actually has a curve and a cant to it, the kind of stuff that is frighteningly expensive, and I try to discourage architects from doing that, but not very often or very successfully. This is the formwork that is the rented concrete formwork and has worked out really well for rammed earth. And here again we see multiple conveyors getting us all the way up to 24 feet in the air. And big formwork with lots of guys in it. So this is what's really changed over the years, is that we've tried to increase the rate of production, because slow production time equates to a whole lot of money, and everything in my way of thinking was geared towards speeding up the construction so that it looked more modern, so more people would use it, and rammed earth would get further up the evolutionary beach, so to speak. Now, the talk that Joe and I titled was The Virtues of Earth. So maybe I've been speaking a little too long and a little too enthusiastic about Earth as a wall system. Because one of the really virtuous things about it is that you can do all sorts of things with Earth. Here we see an Earth floor. So we do a lot of pouring earth. So you mix your soil with sand and a little more cement and a little more water, and you actually treat it like concrete. You can pour it flat and trowel it and score it and make a cast-in-place floor out of it. So this building is all earth. There's an earth floor, earth walls, and even that little infill around the pole rafters under the corrugated roof is more earth. And then you can also pour it into these little brownie tin type things, and you can get tiles to make an earth floor. So there are the forms for pouring pieces into. Here's our casting operation where this wet, sloppy material is being poured into these molds sitting on a vibrating table, and they're rolled out so that you can make a whole bunch of wall caps or floor tiles or anything. So really I can surround myself with earth. Used to do earth roofs, but actually we don't anymore. And so here you see these outdoor elements made out of cast earth wall caps, countertops, swimming pool, coping surround, and tiles all around it. So we live in earth. And here's where we're going with this whole talk. This is Watershed Materials. This is what Joe and I have been working on for the last few years. So trying to make earth popular, I spent all of those years dealing with huge piles of earth delivered to the job site. And why did that happen? I often ask myself. At first we were hoping to use the soil from the site, right? That was the whole idea with rammed earth. You have soil from the site and most of it is usable. And we modified it with a little bit of sand or a little bit of gravel. And then gradually what I was saying happened is that as the walls needed to get better, we quit using soil from the site and we started using it from a nearby quarry. And it was a waste product from the quarry. And I thought, wow, that was easy. Didn't have to dig it up on site, didn't have to screen it. It came from the quarry, and it was their waste product, so they gave it to us. And the first time we used it, we were 3 miles from the quarry. But it was a great material. So we thought, that was a great material. Well, the next time we used it, we were 20 miles from the quarry, and it was still a great material. And then we took it 40 miles from the quarry, and you're looking at the bills come in from the trucking company, and something's going haywire, but everybody loved these walls. And then what happened is, yeah, this is the really funny one. So the quarry was giving it to us for 3 or 4 years because it was a waste material. And I told the guy, I said, hey, Hal ran the quarry. I said, Hal, you know, you can start selling this stuff. Because other people were building rammed earth walls with this same quarry material. We told them that you could use this quarry. Well, he said, that's a great idea. I'm going to call it premium wall blend, and I'm going to start charging for it. Which was fine, but he started charging me for it. He was supposed to charge everybody else so that I had a leg up. So what happened then was instead of using free material from a quarry that was 3 miles away, we started using $18 a cubic yard material from a quarry that was 50 miles away, and the numbers didn't pan out anymore. So rammed earth got expensive and expensive, and I still had this 25-year-old's idealism that we could make it affordable. And I'm thinking, and some other people are thinking on it too, and we decided that the best idea was to get rid of those huge piles of earth in a truck delivered to the site. Throw out 35 years worth of work in developing formwork and delivery systems on site, and we're going to make earth in little bitty pieces. So that's what I'm holding right here, is what we call a piece of earth. And we have been working to develop what we call an earth masonry unit. Concrete masonry units. Cinder blocks are called CMUs, concrete masonry units. So we thought we could develop the method, the machinery, and the formulas to allow us to make earth masonry units. And then you didn't need to be a specialist to build a wall and know how to set rammed earth forms. You didn't have to take all these piles of soil to the site and make it all messy. We would be able to introduce this idea to masons around the world that they could build this super green block with earth and only a little bit of cement and treat it just like a concrete block. So everybody already knows how to lay it. Engineers know how to design for it. Architects know how to detail it. Carpenters know how to put doors and windows into an opening and to put the roof on it. And we are thinking, okay, maybe this way earth will become a widely used building material. So in order to make that happen, what we needed to do was to convince a few clients to let us try it out on them. Fortunately, we had a wonderful lady who we built a Pisé house for some number of years ago, and she wanted to do an addition in her backyard, and I said, let's build it out of our new Watershed block. Then we won't chew up your yard with all of the equipment. So she said, great idea. So this was the very first project that we ever did with the blocks that we made with that little blue machine that you saw right there. First ever Watershed block house. Then we used some Watershed block veneer, where we sawed them in half and glued them to a plywood wall on a second project. And then we built the Austin Hawkins Memorial World Headquarters at Rammed Earthworks facility, where this was Austin's final project after his internship with us last summer. But we experimented with a combination of block and Pisé and our cast elements to build that. And then we began the very first huge full-scale demonstration house to be built with the Watershed blocks. And I'm going to go through quickly here these pictures, and we'll get into some questions, because this is where, well, this is really fun. This is where I'm working right now. We've been on this project for about 8 weeks, and we've sourced our materials from the construction site, which is right there. We started our excavation on this hill in the first part of August. We dug our way into the hill where we harvested rock and gravel and sand and material to build blocks. We processed it right there on the building site. We dug a hole in the ground for the foundations for building 1, excavated the footings, tied steel, set formwork, began laying blocks. We lay 2 feet of block every day. Every 4 feet, you pour grout down the center of the block, and after 4 weeks, we were the top of the building 1, put the floor on it, started building 2 in the background there, keep laying blocks every day, got to the top of this one, put this roof truss on that Austin and my son Kyber welded during the summer. Here we are back at the plant last summer building the roof in advance of building the walls. Took the roof apart at the plant, stacked it up, put it on a truck, brought it to the job site and put it on top of the walls, and kept going with the rest of the project. So the reason that I'm having fun with this is because there's all kinds of new problems to solve. First, you know, we had to make the Watershed blocks and make them strong enough to hold up. Then we had to learn how to lay blocks because none of us were masons. And then we had to learn how to lay blocks quickly because winter was coming on. So it was just one exciting challenge after another. And this is the way it looked yesterday when I left, and I got a phone call that they've set the floor on the other wing, and we're getting ready to put the roof on the other wing in a few days. So this project from start to finish on the site has only been 10 weeks. So we may be achieving this long sought after goal of mine, which is develop an affordable way to build a durable house out of native and raw materials. So in my spare time, just so you know one little bit about me, on vacation, I go to Hawaii and I build houses. This is our house in Hana, Maui, where we tried rammed earth with native Hawaiian volcanic soils and alluviums, and that's the way that house looks next time I go there. So, thanks. Any questions?